scales. Okay, so 4 scales of measurement. So the 4 scales of measurement. So what is basically scales of measurement? Okay, scales of measurement in the sense uh, how your variables. So these are all variables only, right? Okay, so these are all variables only, right? Qualitative data, whatever you call it. So for example, you say uh, height of a person. So you have to put it in the data only, right? So height. So this is nothing but a variable, isn't it? So how can you measure those scales? How can you put those into category? So that we are talking about scales of measurement. How uh, the variables, how the variables are classified. So in simple way, scales of measurement is how the variables are classified. So how can you put the variables, whatever we are discussing, how to put them into categories. So that is what is scales of measurement, how the variables can be classified. So the variables of the, variables of can be measured, can be classified into 4 basically. So first is nominal scale. Nominal scale. And next is ordinal scale, and next is interval scale, and finally ratio scale. So whenever we talk about scales of measurement, we put it in 4 categories. So first is nominal scale, then is ordinal scale, then is interval scale, then is ratio scale. So we will be talking about each and everything in brief. So first, let me talk about nominal scale. So when you listen to this nominal scale, uh, what that comes into the mind is it is used to classify. It is used to classify the categorical variables. So categorical variables means, okay. So in this you can see, sorry, in this you can see something like yes or no. Okay. So yes or no, it is nothing but a categorical variable. So whenever I talk about a categorical variable, so categorical variable means, okay, something like, so for example, if I write something like gender, okay, so gender you say male or female. So you say colors. So colors is nothing but white, black, okay, green, blue. Okay, so this kind of thing. So this are used to classify. So nominal scale means whenever you have data in nominal scale, you are trying to classify them into categorical variables. So categorical variables such as gender, colors, etc. Okay. So what are the characteristics of the nominal scale? So let us understand the characteristics of the nominal scale. So when we try to know about the characteristic, the first characteristic is they are non-comparable. So whenever I talk about non-comparable, so non-comparable in the sense, can you compare male with female? So male is greater than female, female is greater than male. You cannot, right? So that is why they are called as non-comparable. So non-comparable uh, measurements or non-comparable values. Okay. So and the second one is we cannot have any mathematical operations. Okay. So mathematical operations are not possible. Mathematical operations are not possible on these things. So can we have any mathematical calculations on male or female or the colors, right? So we cannot have, isn't it? So that is why I'm saying mathematical operations are not possible. And one more characteristic is we cannot rank them. Ranking is not at all possible. So when we talk about rankings, so I cannot rank male as 1, I cannot rank female as 2, I cannot rank W as, white as 1, what I can say, this blue as 2. I cannot rank them, right? So ranking is not possible. So in nominal scale, so what is basically nominal scale? Nominal scale is used to classify the categorical variables. So for example, the categorical variable examples are gender, colors, etc. Okay, so you have the characteristics such as they are non-comparable. So you cannot have any mathematical operations. You cannot rank them. Okay, so that is what is nominal scale. So for example, as I've told you, yes or no in the previous case, yes or no, true or false, positive, negative, neutral. Okay, so those kind of things you will be calling it as nominal scale. Okay, so then the second one that we are talking about is ordinal scale. Okay, this all data you will be seeing in our data sets that we are going to include. So at that time you need to understand, so what is this type of data, what is this type of data. So that is why we are going to discuss all these things. So ordinal scale means this scale has the properties of, has the characteristics of nominal scale. Okay, an ordinal scale means you can put it in order. That is the meaning actually. So nominal scale, and okay, so it is ordinal scale. It contains the properties of nominal scale, and we can rank them. Okay, so, and we can rank them. So for example, if I am having nominal scale means gender, I was not able to rank them, right. So for now in ordinal scale you will have the proper, I mean the values that are nominal scale values. Now nominal scale means you will have categorical values only, but those categorical values can be ranked. So those categorical values can be ranked. Example, okay, so for example, grades. Okay, so you take grades. So grades are categorical only. Suppose say A, B, C, D. Okay, so I can definitely say that A is greater than B. Okay, so B is greater than C, C is greater than D. Means I am ranking them. So first rank, second rank, third rank, fourth rank. So okay, so that is what I am saying. So rank them. So it is categorical values only. Okay, categorical values only, but we can rank them. Okay, so grades. Okay, so I also told you about sizes, right? So sizes, in sizes you have medium, small. Okay, so medium, small, L, XL, like this. Okay, I can also rank them, right? So what is first? First is small. Small is less than medium, medium is less than L, and less than XL. Okay, so I can also say this. And as I've said, so some of the characteristics, so we will be talking about some characteristics are, first, as I've told you, ranking is possible. Ranking is possible. So when I say ranking is possible, uh, so can we have any mathematical calculations? Mathematical calculations are possible. Mathematical calculations are not possible. So mathematical calculations are not possible means, so for example, if I am saying, okay, can we say rank B is 2 times rank of A? Can this be possible?
No.
Rank B 2 times rank of A is possible? No. Excel is 3 times of L. Is that possible? No. So that is why I'm saying mathematical calculations are not possible. So we cannot compare also, right? Okay. So and the next thing is uh, ordering is important, right? So that is what I'm saying. I said you in the first case, order. So ordering of values is important. Ordering of values is very, very important. So ordering means, so first A, then B. Okay, so that is the kind of ordering you require. So that kind of things are called ordinal scales. So I told you, right, grade, sizes, all these things. Okay, so in the data set, whenever we see, I'll tell you what kind of things are ordinal and all. Okay, so this is called ordinal scale. And then we talk about interval scale. So in interval scale is all about uh, which has nominal and ordinal. Nominal and ordinal. So nominal in the sense it can have the categorical data, and it can be ordered also. Okay, it can be ordered also. For example, okay, so let me just have a definition of this. Uh, okay, so okay, nominal plus ordinal, and they will have a magnitude. Okay, so what is magnitude? Basically, magnitude in the sense, suppose if I am taking two intervals, so let us take temperatures as the example. It will be a good example. So temperature. So when I take temperatures data, okay, so what are the temperatures? 30 degrees centigrade. Okay, 50 degrees Fahrenheit. Okay, this kind of things. So whenever I'm taking temperatures, I said they are nominal, ordinal. So means ranking is also possible, order is also possible. And if we are taking uh, if we are taking magnitude, for example, if I say uh, 50 minus 30, so this is 20. And you can also take 60 minus 40, so this is also 20. Okay, so if this is called interval, right? So this is called interval. So when I take this, so what it is having, this is magnitude, so this is having equal magnitude. Yes or no? So this is having equal magnitude. So when I talk about magnitude between the consecutive intervals, so consecutive intervals means so for example, if I say 10, 20, 30, 40, so these are the consecutive intervals. So what is the difference between 10 and 20? 10. So what is the difference between 20 and 30? 10. What is the difference between 30 and 40? 10. So this is what is called as interval scale. Okay, so basically you will be seeing in graphs and all, right, 0, 10, 20, 30, and you will be having 100, 200. So this kind of scales which takes magnitude into consideration are known as the interval scales. Okay, so what are the characteristics? The characteristics of interval scale are, whenever I talk about the characteristics, comparisons are possible. Okay, so you can compare, right? So 10 is greater than 20, I mean 10 is less than 20, 20 is less than 30. Comparisons are possible. Comparisons are possible. Okay, so then uh, mathematical calculations are also possible. Mathematical calculations, or you can say arithmetical calculations. Mathematical calculations are possible. Are possible. So mathematical calculations means 20 degrees. 20 degrees is double of 10 degrees. So something like that, as I told you. And it contains an arbitrary zero. Arbitrary zero. So arbitrary zero means, so whenever I talk about arbitrary zero, okay, I'll tell you one simple example. So when I say, okay, so let us talk about temperature and velocity. Temperature and velocity. So velocity is nothing but speed. So now I say 0 degrees centigrade. Okay, so 0 degrees centigrade and 0 kilometers per hour. Okay, so when I say temperature is 0 degrees centigrade, so what does this mean? Uh, this means that now the temperature, what say usually what is temperature? Heat, right? So what does this mean? So there is some temperature. There is some temperature. Yes or no? There is some temperature. There is some speed. So it is not that complete heat is not there. Yes or no? So complete heat is not there. So we cannot say that, right? So arbitrary zero. It is not compulsory zero. It's arbitrary zero. So whenever I say 0 kilometers per hour, there is some speed. What is the speed? Speed is 0 kilometers. Okay, try to understand. So temperature 0 degrees in the sense, what I'm saying, it does not mean that there is a complete absence of heat. Okay, so complete absence of it does not mean that it is complete absence of heat. Okay, so it does not mean that It does not mean that complete absence of heat. So the heat is there, but heat is at this particular temperature. Speed is there, but speed is at this particular temperature. Okay, so this is what is arbitrary zero. So your interval scale will contain. So that is what I took the example of temperature, velocity, right? So they can go into minus also. Okay, so they can go into minus also. So temperature also will go into minus. So that does not mean that there is complete absence of heat. So heat is there, but it is in particular temperature. So that is known as the interval scale, and that is known as the arbitrary zero. So whenever I talk about the arbitrary zero, it means that it does not mean that it is an absolute zero. Okay, it is not absolute zero. Okay, so that is what it is. Okay, so for example, in a class there are 0 students. Okay, so 0 students means it does not come under interval scale, because there is no student available. No student available. So this kind of thing is called absolute zero. Okay, so this kind of zero is called absolute zero. So this kind of zero is called arbitrary zero. Okay, try to understand this. Arbitrary zero and absolute zero. The difference between arbitrary zero and absolute zero is arbitrary zero means temperature, that means 0 degrees centigrade and all. So I cannot say -1 student, right? Okay, so I cannot say -1 student, but I still can say temperature is -2 and all. So this kind of scales are known as the interval. And finally, very important, and is ratio scale. Okay, so whenever I talk about a ratio scale means uh, it contains absolute zero. So ratio scale is the kind of measurement which contains absolute zero, which contains absolute zero. Okay, so which contains absolute zero in the sense absolute zero, or it can also be defined as, can be also defined as a measure that contain a, an absolute number. Absolute number. Okay, so absolute number means, for example, height. Okay, so height will be measured in some centimeters or meters. Suppose if I'm saying 1.73 meters, it's an absolute measure. Okay, so if I say weight, so weight, it is also absolute. Weight is nothing but um, so suppose say 60 kgs or something. Okay, so if you say age, okay, so if you say money, okay, currency, so all these are absolute numbers, and they can be absolutely zero also, absolutely zero. So you cannot have arbitrary zero. That is what is meant by ratio scale. And what are the characteristics? Okay, so this gives a tick mark to everything. Okay, so tick mark to everything in the sense, so in our previous scales we had some things lagging for some things. For example, in nominal scale comparisons were not possible, but here comparisons are possible. Comparisons are possible. So comparisons are possible for the ratio scale, and definitely mathematical operations are also possible. So mathematical operations in the sense I can find the average of this mathematical operations are also possible. Mathematical operations are possible, and you can do ranking. Ranking is also possible. Okay, so as I've told you in this case, so we can use absolute zero. Okay, we can use absolute zero. So these are the 4 kind of scales that are available. Okay, so whenever you see the data set, whenever you see a data set, so you need to categorize those data